Okay, this is 5e continued. So this is a continuation off of what we did last class. What we're going to do is we're trying to figure out, your goal is always, we want to figure out what numbers can you put in for x that when you subtract 1, you can take the square root of it. The numbers that are easily square rooted are 0. The square root of 0 is 0. 1, square root of 1 is 1. 4, square root of 4 is 2. 9, square root of 9 is 3. And 16, the square root of 16 is 4. We can go bigger, but these are typically the numbers you want. We always want to start with 0. This is always going to give you your starting point. So we got to think, what number can we put in for x underneath the radical, the discriminant, that's called. What number can we put in for x that we can subtract 1 and it'll become 0? If you cannot think of that number, set the expression equal to 0 and solve. Well, of course you already knew that number was 1, but if you can't think of it, there's your way of doing it. Set the number equal to whatever number you need it to equal. So 1. We're going to now substitute 1 into the equation to solve. Oh, sorry. 1 minus 1, and 1 minus 1 is 0. Square root of 0 is 0 times 3 is 0. So 1, 0. So this is my starting point. This is where the graph for the radical is going to start at 1, 0. Now I'm going to, so that 0 is checked off. Now I'm going to go to 1. So when I substitute 1 in, so I got to think, what number can I put in for x that when I subtract 1, it'll get me 1? If you can't think of it, if it's not off the top of your head, well, set the equation equal to 1. And then 2 should be the number you thought of. When you substitute 2 in for x, you'll get 1, and square root of 1 is a nice square root. So when we put 2 in, substitute 2 in for the variable, 2 minus 1 is 1, and here's the square root of 1. That's what we wanted, was finding 1, getting 1 into the radical. After it's simplified, square root of 1 is 1 times 3 is 3. So our x value is 2, and our y value is 3. So 2, 3. And now I want to get the last one. I want to get 4. And you could do 9 or 16. I just like to stay with a smaller number. So what number minus 1 will give you 4? If you can't think of it, I know 5 is probably the number that's in your head, but if you can't think of it, you set what you're trying to figure out, x minus 1, the discriminant, equal to 4, and solve. So 5 is our answer. So our x is going to be 5. Let's substitute 5 into the original equation. And square root of 5 is 4. That's why we put 4 here, because we were trying to figure out how to get that square root to be 4. Square root of 4 is 2 times 3 is 6. So 5, 6 is also a nice coordinate. And our radicals are always nice curves. Half of a sideways parabola. All right, I am going to jump to number 3. So working out number 3, again, I'm going to look underneath the radical at the discriminant. I got to think, what number can I put in for x that will make it 0, the discriminant? What number can I put in for x that will make the discriminant 1 and 4? And if we want, we can go 9 and 16 or 25, but I'm going to start with 0. So 4x minus 8, if we make that 0, this will give us what x do we need to make the discriminant 0. So it's going to be 8 divided by 4 is 2. So the x value has got to be 2. So we have f of 2 equals a negative 2 plus 4 times 2 minus 8. Eight minus 8, square root of 8 minus 8 is 0, square root of 0 is 0, minus plus the negative 2 is negative 2. So we have 2, negative 2 is my starting point. Now I'm going to go with 1. So we're going to figure out what number can I put in for x that will make the discriminant 4x minus 8 equal 1. So we figure that out, that will give us a nice perfect square. So that's 9 divided by 4, and we unfortunately get a fraction of 9/4. 9/4, 4 goes into 9 2 times with 1 left over, so it's going to be 2 1/4. So this is equal to 2 1/4, or 2.25. Now when we substitute this in, you might think, oh my gosh, this is going to be awful. It really isn't. When you substitute this number in, we already know what the discriminant is going to be, because we said it at the beginning. So we have -2. When you multiply your fractions, you're multiplying the numerators. 4 times 9 is 36. 1 times 4 is 4. So we have 36 divided by 4 is 9, minus 8. And then 9 minus 8 is 1. Square root of 1 is 1. And then plus -2 is -1. So we have our point at 2 1/4. So I'm just going to go a little past 2 and down to -1. There's another point. Now the last one I want to do is 4. So I'm going to figure out what number can I put in for x to equal 4. And some of you might already know this, that's fine. And if you know it off the top of your head, you don't have to solve this. But if you don't, here's a way to do it. So divide by 4, and the x is going to equal 3. So our x is 3. What's our y going to equal? So f of 3 equals -2 plus 4 times 3 minus 8. So when x value equals 3, the y value of our function is going to equal, so 12 minus 8 is 4, square root of 4 is 2. -2 plus 2 is 0. Make sure I got that right. I did. So that is 3, 0. Because those points are really close to each other, if you want to choose another one, like let's try 16. So if I substitute 16 in, so 4x minus 8 equals 16. We'd add 8, so that's 24, divided by 4, so the x is going to equal 6. If x equals 6, then we could substitute. So I'm just doing this because my 3 points are really close to each other. I just want to get another nice coordinate. You're probably asking, do I have to? Well, not technically. I'm only requiring you to do 3 coordinates. So 24 minus 8 is 16. The square root of 16 is 4 plus -2. When the x value is 6, the y value of our function is going to be 2. So it's going to be 6, 2. And so that makes a nice, a little bit easier of a curve. Now when it comes to domain and range, our domain of our function is our farthest left point is 2. So 2, and there's a coordinate there, and it goes to the right forever to infinity. Our range, lowest y value is at -2, and there's a coordinate there, close point, and it goes up slowly, but it always goes up to infinity. All right, let's take a look at, I'm going to choose one more to look at. I'm going to do number 4. Yeah, I'll do number 4. So number 4, I'm going to think about how do I make the discriminant 0? How do I make the discriminant 1? How do I make the discriminant 4? And again, we can go higher if we want. So if I can't think of what number can I put in for x that would make this 0, solve it. So add 4, divide by 4, you're going to get x equals 1. So 1, substitute it back in. 4 minus 4 is 0, like we wanted, 0. Square root of 0 is 0, minus 3 is -3. So our y value is -3. So we have 1 and -3 is our starting point. So that 0 is always going to be your starting point. Now we're going to substitute, figure out 1. So we'll go into 1. So that's going to be 4, add 4, that's going to be 5. Divided by 4, you get x equals 5/4. So we get a fraction. That is approximately 4 goes into 5 one time with 1 left over. So that's going to be just a little past 1. Substitute that in. And what's going to be scary to substitute in a fraction. But fractions are something we can work with. And then we have 4 times 5 is 20. 1 times 4 is 4. So multiply your numerators, multiply your denominators, and we'll get that to be 5. And the square root of 5 minus 4 is 1, so which is exactly what we want it to be 1. And the square root of 1 is 1, minus 3 is negative 2. So 1 1/4, just a little past, negative 2. So we're getting a similar situation to my last one where our points are really close to each other. So we can try 4, or we can go bigger. You could try 9 or 16. I'm going to try 4 just to see. Oh, sorry, 4, not 0. Where'd it go? And add 4, you're going to get 8. Divide by 4, you get 2. So our x value is 2. Then we substitute that in. So when x value is 2, our function, our y value is evaluated at our function at 4 times 2 minus 4 minus 3. 8 minus 4 is 4. Square root of 4 is 2. That's going to be negative 1. So we have 2, negative 1. So it's really not spread out too far. 3 points is really all you need. We're just going to draw a graph like this. Domain, x values start at 1. That's the x value here is at 1. So that's 1 to infinity. Our range starts at a y value of negative 3. Is our lowest y value. And it goes up to infinity. Keeps going up as you go along to infinity.